Today we're looking at Lesson 3.1, Solving Inequalities with the theme of physical fitness, inequalities and their solutions. Our learning targets are understanding what it is meant by a solution of inequality and graphing solutions of inequalities on a number line. So let's see. Spartan Middle School students participate in physical education testing each semester. In order to pass, 12 and 13-year-old girls have to do at least 7 push-ups and 4 modified pull-ups. They also have to run 1 mile in 12 minutes or less. You can use an inequality to express the passing marks in each test. So let's look at our chart. With push-ups P, verbally they have to at least have 7 push-ups. So at least. That means it could be more, it could be exactly 7, but it cannot be less. So this is the sign we would like to use, the greater than or equal sign. P is greater than or equal to 7 for at least 7 push-ups. On our graph, we would have our number line. We start at 7, and everything that's more than 7, we kind of shade in, going towards the right as it gets bigger, covering the numbers that are more than 7. The modified pull-ups, M, at least 4 pull-ups. So at least 4, same as at least 7, we want it to be 4 or more. M is greater than or equal to 4. Don't forget the little line underneath the greater than sign to make it greater than or equal. And then on our number line, we have 4, and we cover everything that's more than that. On the 1 mile run, R, it's 12 minutes or less. Or less. So R is less than or equal to 12. So every number that's 12 or smaller. And on our number line, we show that by shading in from 12 all the way to the left for negative numbers eventually. Another thing we should note is that the circle that we start with is fully darkened on all of these because we're using the less than or greater than or equal signs. If it was just plain less than or greater than, that's when we use an open circle. And excuse the messy drawing. It would look something like those. If it was just a plain sign, this would be that number, and everything less than it would be shaded. For a greater than, this would be a number so that we can shade everything greater. So let's look at number 1. Why do you think the graphs of push-ups and pull-ups are dotted, but the graph of the mile run is a solid ray? Well, if we look at our graphs and think about it, at least 7 push-ups or 4 pull-ups. The reason that it's dotted and not shaded in is probably because push-ups and pull-ups are either or kind of things. You can do like 5 or you can do 6, but it's really hard to say that you did 5.5 push-ups because you didn't make it all the way. It doesn't count. So we'll say that there are either or activities where there is no in between. While running, there is an in between for 12 and 11 minutes, or 10 minutes. You'd have 10 minutes and 20 seconds. So we'll say that run is an activity that has Gradients is the word for that. It just means in between. Cover in between full integers, we'll say. Number 2, reason quantitatively. Jamie ran 1 mile in 12 minutes 15 seconds, did 8 push-ups, and did 4 modified pull-ups. Did she pass the test and explain? Well, we have to look at our minimums. At least 7 push-ups. She did 8. She's fine there. So we're going to say she did enough push-ups. All right, did 4 modified pull-ups. You needed to do at least 4 and pull-ups. 12 minutes and 15 seconds. However, she did not get that. She needed 12 minutes or less, and she was just over 12 minutes, so she did not pass. So she did enough push-ups and pull-ups, but she was over time on running the mile. 15 seconds. And that's just looking at our chart, looking at the times that she got, reasoning it out, thinking about it. They're not trying to trick you. They just want you to actually think about what information they're giving you. 3, Karen did 7 push-ups. Is this a passing number of push-ups? Which words in the verbal description indicate this and explain? At least 7 push-ups. She did 7 push-ups. That is a passing number. So it is a passing number because it is at least 7. That's the word in the verbal description that indicated at least 7. How is this represented in the inequality p is greater than or equal to 7? It is the part at p equals 7 of that inequality. All right. The solution of an inequality in one variable is the set of numbers that make the inequality true. To verify a solution of an inequality, substitute the value into the inequality and simplify to see if the result is a true statement. Basically, just like we did for our equations, when we put the number for x and see if it worked out, we're going to do the same for inequalities. We're going to see if it's still less than or greater than or equal or less than or equal to the number that we're saying is our solution. Number 4, using the tables below to figure out which x values are solution to the equation and which ones are solution to the inequality. Show your work in the rows of the table. So let's look at this. The values they give us over here. And we want to, oops, hold on. All right, I've messed up. Hold on just a second. That wasn't the one I was doing right here. So -1, we'll say, is 2 times -1 plus 3 equal to 5. Is that a solution? Well, 2 times -1 is -2, plus 3 is 1, and 1 is not equal to 5, so that's a no. Let's see if that lets me write a little bit more. 1 is not equal to 5. I don't think there's a sign for that. At least on this computer that I'm using. It would be a sign where you just have an equal sign and you strike through it like this. But it's hard to do right now. Solution to the inequality. If I put the same thing, 2 times -1 plus 3, is that going to be greater than 5? Well, it's 1. The answer we got, 2 times -1 is -2, plus 3 is 1. Is that greater than 5? No, it's still not the solution. Okay, 0, 2 times 0 plus 3, is that equal to 5? Well, 2 times 0 is 0. 3 is not equal to 5. No. But is 3 greater than 5? So that's a no also. One is 2 times 1 plus 3 equal to 5. 2 times 1 is 2, plus 3 is 5. 5 equals 5. Yes, that is a solution. But is 5 greater than 5? No, it's not a solution to an inequality. 5 is the same as 5. It's not greater than it. 2 times 2 is 4, plus 3 is 7. 7 equal to, sorry, I was thinking out in my head and I wrote it. And I'm still not writing what I want to. All right, 4 plus 3 is 7. Is that equal to 5? No. Is 7 greater than 5? Yes, it is a solution to this inequality. It's not a solution to the equation. There's only one solution to the equation, and that is when it's 1. Well, that might be a question in a minute, but we'll keep going. 8.5, let's see what 2 times 8.5 plus 3 equals 5. Well, 2 times 8.5 is 17, plus 3 is 20. 20 is not equal to 5, so that's a no. But is 20 greater than 5? Yes, so it is a solution. Okay, multiple solutions to inequalities, usually, at least right now, only one solution to this equations. Number 5, how many solutions are there to this equation? One solution. That gives the correct answer. Which numbers in the tables are solution to the inequality? Are these the only solutions to the inequality? The ones that were in the table that gave the solution were 2 and 8.5. They are not the only solutions. Any number that would work out, that would have the inequality, to be greater than 5 would be a solution. So if we put 10, 2 times 10 is 20, plus 3 is 23, that is greater than 5. 100, 2 times 100 is 200, plus 3 is 203, greater than 5. Yes. Okay, any number that we can get that works this out to be greater than 5 is a solution for this inequality. While we looked at this equation, there was only one number that we could find in this chart that gives us exactly 5. Would 1 be a solution to this inequality? 2 times 1 is 2, plus 3 is 5. Is 5 greater than or equal to 5? See, they're trying to trick us. They made it a greater than or equal sign this time instead of just greater than. So it would actually be a solution to this equation. So yes, 1 is at least 5. Remember, at least is this word for greater than or equal, because it could be anything more than 1, and it could be 1. Yes, 1 is at least 5. I'm sorry, not 1 is at least 5. 1 would give an answer. It would make the inequality. One would make the inequality at least 5. Not 1 is, that didn't make sense. That's why I had to change that. Yes, 1 would make the inequality at least 5. You could say expression for just this part. Term is another word for the piece that we're looking at. Here are the number line graphs of two different inequalities. X is less than 3. And you can see, look, open circle. It's not all the way colored in. And everything less than it is shaded. And x is greater than or equal to -2. It is shaded in over the 2 to make it certain that you know that you include -2 in the answer. And everything bigger is shaded in. Use the graphic organizer to compare and contrast the two inequalities and graphs that are shown above. We just want to put in this table words that we see happening. Similarities, both shade the number lines to include solutions. Differences, one is, let's see, how do I want to say this? One has the starting point shaded and the other open to reflect the sign used. Let me say it like that. So that is a very important detail. You must remember, open circles are for less than or greater than only. Closed circles are for less than or greater than and equal to. So greater than equal to, less than equal to. That's closed circles. That helps a lot if you are taking a test and they ask you to identify it. Well, you can already kind of look at the answers and say, well, it's either this one would have to be something with greater than equal to or less than or equal to, depending on which way it was going, just because it's closed circle. You can count off these answers that had plain less than or greater than, because you know they would look like this. So you want to be able to just quickly identify what signs are being used. Then you can move on to what numbers are being shown. Then you have the whole thing. 9. Think about why the graphs are different. Why is one of the graphs showing a solid ray going to the left and the other graph is showing a solid ray going to the right? Okay. Remember, they're just getting you to think, not trying to trick you. The one going left is covering numbers that are less and getting smaller. The one going right covers numbers that are greater and getting bigger. Why does one graph in an open circle and another graph a filled-in circle? I've already explained it like multiple times, thinking ahead, I guess, but that's just how ingrained it becomes into you that you want to point stuff out when you know it. But basically, open circle is for greater than or less than signs. Closed circle includes the number as a solution. With, and I won't have to draw it, forgive this, but less than or equal to, greater than or equal to. There is a way to use these to put the answers in, but currently, because of the weather, we don't have the internet, so I'm doing the best that we can. You just have to go along with us. All right, now I want you to check your understanding and work numbers 10 through 18. Okay, try the rest of these questions. Writing the inequalities here, you just need to put it so that it looks like these. Okay, use the right signs, facing the right way. When it asks you to write the inequality, just use what they give you and write it. That should be simple enough. Okay, remember the key words: no greater than, less than, must be at least, can be at most. Those are the words you need to pay most attention to when deciding which sign to use. Number 11, you're just going to see how the graphs are different. There is a key difference between them. Just tell me what it is. And the last couple, they want you to actually graph the numbers on the number line. If you can't get this, if you can't get the number line to work in one of these, I want you to test it out and try it. But if you have your physical copy of the book, you can draw them in there. Like x is less than 2, it would say number line 0, 1, -1, -2, less than, so it would be open circle, and less than, everything to the left would be shaded. Everything to the left would be shaded like that. Your number lines don't have to be perfect, but you do need to have some numbers on there that are like your light posts or lamps that show you where you're going to be. Guideposts, something like that. So try these.